There's a pattern in how financial infrastructure develops. It starts as a product, something users interact with directly, with a UI, a brand, and a customer base. Over time, the product's core capability, its settlement engine, its risk model, its pricing infrastructure, becomes valuable enough that other products want to plug into it. The original product doesn't disappear. It evolves into the layer that other things run on. We've seen this in traditional finance. We've seen it in Web 2. And I think we're starting to see it take shape in DeFi, specifically with LeverUp on Monad. That's what I want to walk through today. Let me start with a question. What does financial execution infrastructure actually do? At its core, it handles three things. Pricing, determining what something is worth at the moment of transaction. Settlement, moving value between parties. And risk management, ensuring the system stays solvent when conditions go against it. On a traditional exchange, those three things are bundled together. On most DeFi perp exchanges, they're partially distributed. LPs absorb settlement and risk. Oracles handle pricing. But the coordination cost is high, and the system is only as reliable as its most variable component, which, in LP-based systems, is often LP behavior itself. LeverUp handles all three at the protocol layer. Pricing is Oracle referenced through Pyth Pro settlement runs through a protocol-managed virtual liquidity architecture. No LP capital needs to be allocated or withdrawn. And risk management, collateral ratios, liquidation parameters, position limits, those are protocol functions, not distributed across LP decisions, not dependent on what LPs choose to do. The practical consequence of that design is important. Execution capacity depends on protocol risk parameters and collateral conditions, not on the depth of an externally supplied LP pool. That's a fundamentally different operating model, and it has real implications for what can be built on top. Let me talk about composability, because that's where the execution layer thesis really starts to crystallize. LP-based systems have a coordination problem. Liquidity providers deposit capital, take directional risk, and can withdraw at any time. Any product that wants to build on top of an LP-based system is, structurally, building on a behavioral capital layer, one that may leave when conditions change. That's not a criticism of LPs. It's just the reality of the incentive structure. Protocol-managed virtual liquidity doesn't withdraw. The protocol's risk capacity is a function of its parameters and collateral, not of LP sentiment. This means a product building on LeverUp can rely on consistent execution behavior. The pricing model is Oracle referenced, so inputs are predictable. The settlement layer doesn't require LP coordination. Risk parameters are on-chain and auditable. That's what an execution layer requires. Parameter-driven behavior that other systems can depend on without managing the underlying capital dynamics. It's the difference between building on sand and building on bedrock. Now let me walk through the three architectural pillars that make this possible. The first is AnyCollateral. Every ecosystem token LeverUp accepts as collateral is a token that doesn't need to be converted to USDC before it can be used as margin. MON holders can use supported assets as trading margin without selling them first. Eligible LVMON can be staked for variable rewards or used as supported collateral for trading. This isn't multi-collateral as a convenience feature. It's a different theory of capital efficiency. Assets stay in their most productive form, and the protocol absorbs the valuation complexity through collateral ratios. As more Monad ecosystem tokens become eligible, LeverUp's collateral layer starts functioning as a Monad-native standard for how assets interface with leveraged positions. The network effects compound with each integration. The second pillar is Oracle-referenced pricing. Because LeverUp's pricing is Oracle-referenced rather than AMM curve-derived, Execution is not dependent on an AMM pricing curve. Oracle reference pricing helps reduce pricing latency and stale pricing risk, while protocol parameters continue to govern execution and settlement. Why does this matter structurally? Because programmatic trading flows, AI agents, automated hedging systems, systematic strategies require predictable execution to operate safely. They need to calculate expected costs and outcomes before transacting, not just after. An Oracle-referenced execution layer is structurally better suited to those kinds of programmatic counterparties than one where execution quality depends on curve depth and routing. The third pillar is the protocol-managed risk engine. In LP-based systems, risk is partially distributed to LPs who absorb losses when the aggregate book runs net negative against them. That creates misaligned incentives. LPs bear risk they didn't necessarily choose, and the protocol has to balance LP economics alongside trader needs. LeverUp's risk engine operates independently. Collateral management, liquidation parameters, and position limits are protocol functions. The system's risk capacity doesn't depend on external parties choosing to remain. So what gets built on this execution layer? Let me sketch 3 directions. The first is AI agents. Autonomous agents executing financial strategies require clear execution inputs and reliable settlement rules. Oracle reference pricing with on-chain risk parameters is structurally more legible for agent developers than pricing dependent on AMM curve depth and routing. The current architecture already supports programmatic interaction. What's needed is API standardization and documentation that makes the execution layer accessible to systems that don't need a front end at all. The second direction is RWA integration. Tokenized real-world assets, T-bills, commodities, equities, create natural demand for leverage and hedging. Holders of tokenized T-bills want to express views on interest rates. Holders of tokenized commodities want to hedge their exposure. A protocol that accepts ecosystem assets as collateral is one that can absorb RWA assets as they arrive on Monad. AnyCollateral is the gateway. As the Monad ecosystem develops its RWA base, LeverUp's collateral layer becomes the natural connection point between asset holding and leveraged position taking. The third direction is embedded finance. Applications that want to offer leveraged exposure without building their own execution infrastructure can route through LeverUp's protocol layer. Users of those applications may never interact with the LeverUp interface. The embedding product owns the UX, while LeverUp handles pricing, settlement, and risk. Wallets, Telegram bots, AI assistants, DeFi aggregators, any of them can offer execution capability without building it from scratch. This is the embedded finance pattern, infrastructure that runs behind interfaces it doesn't own. There's one more piece that makes all of this work at scale, and it's the chain itself. Execution infrastructure doesn't work on a slow chain. The freshness improvement that Pyth Pro delivers is only meaningful because Monad's throughput can process the resulting transactions before the price data becomes stale again. Oracle freshness and chain throughput are codependent. Fast, reliable execution requires a chain that can settle transactions quickly enough to stay synchronized with the Oracle. Monad's architecture, high throughput, parallel execution, EVM compatibility, is the environment where this pattern can operate at scale. A slower execution environment would reduce the benefit of low latency, Oracle-referenced pricing. It's not a coincidence that LeverUp is building here. I want to be precise about something before I close. This isn't a product announcement or a roadmap commitment. It's a read of what LeverUp's current architecture enables and where that points. The execution layer pattern emerges from architectural choices that are already made. The protocol-managed virtual liquidity design. AnyCollateral, Pyth Pro integration. These aren't features selected because of some infrastructure ambition. They're features that, taken together, create the conditions for the infrastructure layer to become real. Whether that potential gets realized depends on what gets built on top. But the structural conditions are there, and in DeFi infrastructure, that's usually where things start. If you want to go deeper on the architecture, the What is LeverUp article is the right starting point. Link is in the show notes. And if you want to see the execution layer in action, the trading app is live at app, LeverUp, Zeiss. As always, this is not financial advice. Understand the protocol before you trade. I'll see you in the next one.